Hello everyone, this is the video lecture for Algebra 1314, section 2.2, and we're going to have more fun. Yeah, more fun. Yeah, F-U-N, look. I never noticed that, that's so cool. Anyways, we're going to have more fun. Such a dork. Anyways, so intervals are based on x values. They're like mini domains. I'm going to talk about this here in a second. Never use this, always use that. And then read left to right like in English. Okay, so what are they talking about here? We're talking about increasing, decreasing, and constant. Basically, increasing is going up, decrease is going down, constant is flat. There you go. So up, down, and flat. And so as long as we're using these x values in parentheses, we're good to go. Now, I've had a lot of people ask about why we use parentheses. I would say take a couple advanced math classes and then you'll start to find out. There's no need to explain it all here, but I mean, it's good enough. Use parentheses, okay? So where is this thing increasing? And so we're looking at this graph, and I absolutely need a different color, okay? So I want to know, where is this thing increasing? And, oh man, these arrows. Oh man, these arrows. Just go ahead and get rid of these arrows, okay? Because they're going to just throw you off, okay? Just stop. I'm reading left to right. I'm going this way. So where's it increasing? I'm following the line, and we're going up here. So we're starting way over here on the left. Ooh, where's that word again? Left. Yes, negative infinity. And we're going in until 0. That's the x value. The x value is 0. Increasing. We're also increasing right here on this little chunk. And so we're going here from 1 all the way until 2. X values. X values. It just said it right here, x values. I don't care how high. So where is it increasing? Negative infinity to 0, comma 1 to 2. Hold up. Hold up. That's true. I don't know if they're going to want you to use a union or not. It probably is just parentheses. But if they want to use a union, it's basically like a comma. Did I say parentheses? I meant comma. It's probably just a comma with the parentheses. If they want a union, there's a special button for it. You just click it, and there you go. So either way, we got those two places where it's increasing, okay? Again, left to right, reading it like English. Okay, so let's do this whole thing for the decreasing part. I'm going to do some blue action. Blue. All right, decreasing right here. We're going down. Boom. Decreasing. Boom. Decreasing. See how I had to get rid of those arrows? They were so annoying, weren't they? I mean, it totally don't tell you what's going on. No arrows. So we're going from 0 to 1, and then we're going from 2 to the right side. Yes, we're going to the right side. Where did I have seen that before? It's positive infinity. 0 to 1, 2 to infinity. There you go. Only x values. I know you're thinking, oh man, that's going down. Isn't that a negative infinity? No, because that's a y thing. We're talking x values. I'm going from left and right. This way. You just got to have it. You got to. Oh, wait. Where's the constant? Where's this thing flat? It ain't. You put none. Now, there are more questions like this on your homework. I would say that they're kind of easier than this one. But at the same time, so often people get the y values confused. They're going to say, oh, I went all the way to negative 1. I'm like, nuh-uh. I ain't in it. You're going to 0. Okay, so watch out for that kind of thing. All right, now, I just made a whole mess of this picture. Ha, ha, ha. And they want me to keep going. So, so I'm going to use a different color, of course. So let's do some green. Woo, green. Lime green. Man, that is going to pop. Ooh, man, that is way too poppy. Hold on. Let's kind of subdue my green a little bit here. That's a little bit better. Okay, so they're talking about maximums and minimums. They're saying the top of a hill or the bottom of a valley, okay? They're not saying Mount Everest. They're not saying the bottom of the Atlantic Ocean. Maybe it's the Pacific. Either way, we're not saying the very top, very bottom, though it could be. I'm saying just the hills and the valleys. So where do I have hilltops? I have a hilltop right there. I have a hilltop right there. So I got two of them. And so I need to put x equals some numbers, and then here they're wanting y equals some more numbers. What are my x values? 0 and 2. What are my y values? -1 and -1. Now, this is where my math lab's a little weird. See how they're repeating? I think you can just put a single y equals and it's okay. I don't know. Either way, try it out. It'll be fine. There you go. Those are my tops of the hills. Do I have a bottom of the valley? I do. X equals what? That's a 1 technically. And then my y value equals what? It's way down here. -5. There it is. We're done. Did you notice that the wording, the words, is something that I didn't read? And that's what my math lab's going to give you. It's going to say the number at which the functions of the relative blah, 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 and the relative maximum is this blah, blah, blah. It's like, yeah. What? It's x and y. That's all that really is. It's just x and y, okay? So don't overthink it. It's totally fine. There we go. All right. Even, odd, and either. I love these topics here. It's so cool. But I can't have green. Got to go back to the black. There we go. So, even, odd, or neither. Do I have something here on my workbook? Because you know me. I got to have something, like, perfect. Just for you. Here we go. I do. I have something written down. How nice of me. So, here we go. Y-axis symmetry. And I'm also going to put even powers. We're going to talk about that. Odd is origin symmetry. And I'm going to say odd powers. Again, this is more of like a Chad thingy. All right. I'm sorry. I can't do it. This thing right here, I ain't doing it. And this thing over here, I'm so sorry. I know there's a proper lecture that somebody else has on this topic, and they do a fine job of it, I'm sure. I haven't done that thing in the past, 10 years, so whatever. But I will show you how to do it, I would still say properly, and easily as well. It's an easy topic. It's really fun. Here we go. So even and odd is talking about the symmetry. And so this is like the symmetry on your face. See, it's like y-axis symmetry. You got an eyeball here, you got an eyeball here. You got like half of a mouth, you got the other half of a mouth. You got one nostril, you got the other nostril. You got one eyebrow, you got the other. You get the idea, right? So there you go. It's y-axis symmetry is something like that. I'm not an artist, obviously. But hey, you know what? All right, anyway, so I'm sorry. So that's really cool. Origin symmetry says that there's a symmetry somehow involved about this origin point here. And look at it. Do you have like a feeling that something is symmetric here? It has a feeling, right? Now, a lot of people do like the page flippy thingy, and I don't want to. I'm not. I'm going to show you the clock. This is like a clock. I'm going to take this hand and tick, 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 tick. Tick, 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 tick. Oh my goodness. Can I wind it up so that eventually the two hands are on top of one another? Yeah. They were revolving around the origin. There you go. It's like a clock. Now, the hands are always a little weird, but that's fine. Another way to see this is opposing quadrants. So these opposite quadrants should be symmetric. So this guy should be the same as this guy. Or the blank should be equal to the blank. And there you go. All right, awesome. So, back to this thing. It says even powers and odd powers. Look right quick at this guy. What are the powers that you're looking at? Look, 2. That's even. Awesome, man. Awesome. Don't look at that 4. Don't look at that 4. I said even powers. What's the power going on here for x? It's actually 0. It's actually 0. How many x's do you have right there? 0. This guy right here? Even. This guy right here? Even. So what is this guy? Even. Just saying. Right here, look at this one. Let me rewrite it. X cubed minus 4 times x to the what? What's the power? How many x's do we got? 1. Look at this guy. Odd. Look at this guy. Odd. It's odd. Okay? Keep that in mind. Here we go. Bam. Yeah, we're going to do all these here, and we're going to do them super fast and easy. Now that we're just looking at the powers. It really is just this easy, okay? So, I'm looking at this guy. I got a 5. I got a 3. Odd. 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 That was it. Okay, let's do it again. So look in here. I've got even, even, even. Woo! Yeah! All right, all right. Hold up, hold up, hold up. I got x to the 4, and I got x to the 1, even, odd. Can you have a number that is both even and odd at the same time? The answer is no. 0 is even. No. So you have to say neither. You can't be both. You can't be both. Let's do this one. So that's x to the 4 plus 3. How many x's we got? How many x's? None. Even. 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 We got it. All right, here we go again. X to the 7 minus 5 to the x to the what? X to the what? Come on, come on. 0. It's 0 because there's no x's there. It's nothing there. Odd. Even. It's even. Yeah, you're thinking, hold up. How do you know it's even? 2, 4, 6, 8, 10, right? Dot, dot, dot. Those are my even numbers. Come on. What would be the number that sits right here? It's got to be 0. It's even. Odd and even? Can't have both. Neither. There it is. Last one. X cubed. X to the what? How many x's we got there? Come on, look at it. 1. 1 x. We got an odd number. Got an odd number. What do we got? Odd. You got it. Sorry, this is it. That's it, man. You can go and do all that hard math. Go on. Go back and do that formula. No. I don't want to do that formula. Just look at the powers. It's fine, man. And it gives you a little bit of insight. Gives you a little bit of thinking, right? How many x's do we got here, right? What power would I use for this guy? It makes you think. It's a good thing. Okay. So that was a fun topic. I love that topic. It's a great topic. This topic, hate it. I'm so sorry. I shouldn't be saying that. I love all math. Math's awesome, man. Yeah, okay. So this is called a piecewise function. If I could spell it, that is. Piecewise. Because there's a couple pieces in there. I am so happy for today's sponsor is Desmos Graphing. And we're going to show that and how we're going to do that with the piecewise functions. So right now, they're just wanting me to give you an example. And I'm going to give you the example that I wrote down. So x plus 1, I'm going to say x is less than 1. And then I got x squared as long as x is greater than or equal to 1. Blah, 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 a lot of ones. So what is this thing, what is that graph going to look like? It kind of is going to look like this right here, okay? Yay! Okay. Piecewise means that there's this big curly going on, and there's two separate functions at once. These are called your constraints, and that's your function, I guess? I don't know. Your constraints. So these are kind of like mini domains as to where it's located, and one is the hot number as to where we're going to talk about. See, it says less than 1. That's going to be on the left side. This is the left side over here. This is left. And then this guy right here, when it says greater than 1, that's on the right side. That's all this stuff over here, the right side. Okay? So we got left side, right side, two different functions. There you go. Before I keep going, I want to show you how to graph this in Desmos, and then we're going to use it again for another problem or two coming up, okay? So just so that you can kind of see what to do in this very odd situation. Okay, so normally I just say, oh, you can just graph both of them, and then you put them together, and everything's happy. Look at that guy. No. We're going to do way better than that, okay? So for a piecewise, you're going to have to do the curlies, but you have to put the constraints first. So you have to do x less than 1, and then a colon, and then a colon, and then x plus 1, close off your curlies. Notice that it's the same line that we had, but it stopped. And where? Where did it actually stop? Oh my goodness, that looks like that's x equals 1. Whoa! And if you like hover on top of it, oh, is it going to let me? Is it going to let me? Oh, I can't touch 1. And the reason why is because it doesn't exist. There's a hole right there. Just saying. Okay, anyways, curly, again, the constraint comes first. So x greater than or equal to 1. Whoa, Chad, how'd you do that? I don't know. So I type it in there, and we get this cool graph. Look at that. Yay. And then look, I can actually sit on that problem, on that point. Yay. Anyways, how did that little equal sign happen right there? What it was going on is that there's it looks kind of like that. It looks like that whenever I'm typing it. I'm putting like an actual equal sign. And, oh, there it is. See, no equals. I hit the equals button. Here it is. Here it is. Did you hear that? Did you hear that? Hold on, hold on, hold on. Here we go. Anyways, we're not going to use that right now. I'm going to use Desmos Scientific for a lot of this stuff. I know it says to graph it. You only have to graph it like twice, maybe on the homework. Anyways, so let's do this problem right here. More so this stuff. I want more room for this stuff because it's way more important. So I've got, these are all f of x. So I got x is negative 3, and it says, where does it go? So is negative 3 less than 0? I'll wait. Yes, it is. So I'm going to use this guy when plugging in negative 3. So 3 times negative 3 plus 3, negative 9 plus 3, negative 6. That was it. There's your answer. Negative 6 right there. We're done. Yeah. Okay, let's keep going. Is 0 less than 0? Is 0 greater than or equal to 0? Technically, yeah. There's an equal sign right there. So I'm going to use this guy right here to plug it in. 4 times 0 plus 7. Nah, 7. That's your answer. And then finally, 3. Is 3 less than 0? No. Is 3 greater than or equal to 0? Yes. Use this guy again. 4 times 3 plus the 7. 12 plus 7 is calculator. No, it's 19. I don't think on your homework that you have to graph this one. It is actually pretty brutal. I mean, if you were having to actually do this by hand, oh my gosh, that would be not fun at all. Nobody wants to do this. In fact, you're technically not capable of graphing this right now because we need to go to the next section in this chapter in order to graph this at all. But, you know, in the meantime, yay, it looks something kind of like this, and you had a fun time doing it. Anyways, I'm not going to graph this one at all because it doesn't make sense. You're not going to be doing the graph for this one. It's not a big deal. But we are going to be plugging it in. That is important. So here we go. Is 0 less than or equal to negative 3? Yes! No, 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 it's not. 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 Is 0 between negative 3 and 3? Yes. Plug it in here. 0 plus 8 is 8. Good. Okay, negative 3. Is negative 3 less than or equal to negative 3? Yeah, because of the equal sign down there. So negative 5 times negative 3, plug it in right there, positive 15. 4. Is 4 greater than or equal to 3? So 4 squared minus 10. 16 minus 10 is a 6. Last bit, negative 4. Negative 4 is less than or equal to negative 3. Yep, using this guy one more time. Negative 4, or negative 5, negative 4 makes a positive 20. You just got to know where to plug them in, you know what I mean? Find the right one, and then you plug it back in for it. All right, this one is an actual graphing problem on your homework. It is important to you. Here we go. Let's do it. It says, what's the graph? And I don't even waste time, man. I don't even waste time. I'm just going right to Desmos with this guy. And I want to make sure that you're seeing how I type this guy in. You have to do the constraints first. And I am so prone to not doing that right. So, here we go again. All right, so let me just write it out so that you're writing it out too. If I don't write it, you don't write it? I don't know. I hope not. Hope that you're writing a lot more than what I'm doing. There you go. All right, so that's what I typed into Desmos. And doesn't look like nothing, Chad. Home button? Ha-ha! It's this guy. We can go through all the details about why, but again, you technically can't do this problem yet because you need to go to the next section. We're in 2.2. If you go to 2.3, that's when they're going to tell you how to graph lines. Same thing with this one. I think the best way, if you did not have a calculator, let's just say, is to make a table. Yeah. Have you done this in a while? So then you start with, say, like negative 10, negative 9, negative 8, negative 7. No. I would really, really rather do this one in Desmos, and especially for this class, Math 1314. It says right here is your function. It says find the graph. And I am not going to stick around on this one. It is totally worth it to just type it in, get the answer, and you're good. Look, there's a line. It's a line. No, you got to zoom out, man. Look, see? This one. There it is. We did it. Okay, cool. So if you're confused about that one, make a table. That's what I would say. And we're done. Yay! Thank you very much. Have a great day.